Am I doing better about not walking out of the screen? I think sometimes my head's out of the screen, but as long as my image is in there, the stuff I'm doing. Okay, so there's just a few things I want to add to this. Do you remember last year when we would solve polynomial inequalities? So let's just say, so you know what a polynomial is, right? And I think you know what an inequality is. So let's just say I had something like this. Are you with me? And I said, solve. Well, we've already learned how to solve the equality part, right? How do I find out where this thing is equal to 0? And I'd love to be able to factor it, but since I can't really factor this guy, what would I do to find out where it's equal? And you should know this since it's what we covered this chapter. Come on, how do you solve a polynomial of the power of 3 or 4 or anything?
Use the synthetic division.
We do know this, right? Are y'all just holding out on me? It's going to be a rough Monday. All right, we're solving. We got to pull out our possible rational roots. We start synthetically dividing. So I've got quite a few possible rational roots. All right. Now I might take a quick look at Descartes and what he says about this, but it's plus, minus, plus, plus. That's not alternating or the same. So I doubt I'm going to get much from Descartes. It's really going to save me time. Like it's probably going to cost me more time just doing it. So I would probably jump to actually starting to factor. And as you start guessing and whatever, you finally find that -1, +2, -3, +2, -3, and then actually +2 again. You find that those 4 factors actually check when you do synthetic division. Okay, I'm not going to waste your time with it. So once you get it all factored, now you would do this. So again, I'm trying to save us a little bit of time. So you ended up with an x plus 1, an x minus 2 happened twice, so that was squared, and an x plus 3. I'm hoping this rings a bell, but if it doesn't, it has been a while. Now, what do you do? These are the places where it's equal. What do I do to figure out where this statement is true? How does the inequality come into play? Do y'all have any memory of that? We did it last year in about chapter 4. So, I mean, it was first semester for sure. So this is not an x and a y, it's just x's. So we're thinking number line. And I know it's equal, because the equal sign at -1, -3, and 2. What is the inequality going to do to this?
We check each one of the 2.
So it's gonna show some shading somewhere, right? That's what all inequalities end up doing, right? And if it wasn't equal, if it was just 0 greater than all that, it would just be open circles, right? But I don't know where it's shaded, so I'm going to come in here and check. And I'm just going to check all 4 places. All right, so when I come in here to check, I'm going to say, all right, well, what about -4? I can plug a -4 in the original, but that's going to be a lot of math. I'd rather just plug, say, a -4 in here and see if it's true or not. And it's true if it ends up being smaller than 0 or negative. If I plug a -4 there, I get a negative. Anything I plug in here is going to be positive because I'm squaring it. And if I plug a -4 in there, it's negative. But a negative times a positive times a negative is positive. So that's not true, is it? So don't shade that. If I check a -2 in here, I get a negative. That's always positive. But now I get a positive here. Well, plus plus negative is negative. That is true. I'm going to shade that. If I check like a 0, I probably would check in the original. Because 0, all that goes away. Is 0 bigger than 12? No. So I'm not going to shade that. But you're welcome to plug it in here. Plus, plus, plus. not true. And if I plug a 3 plus, 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 not true. You with me? Now you might remember me talking, it's not, to me, it's not really worth the extra brain cell, you know, using it towards this because you can always check. But we did say if there was nothing raised to an even power, it would always alternate. But if it is raised to an even power, at that root, it doesn't alternate. So you can see that, look, not shaded, shaded. Not shaded, but that's an even root, so it remains not shaded. If that had not been an even root, it would have been not shaded, shaded, not shaded, shaded. But again, it's not really worth memorizing. That's with even roots. All right, and if I turn this inequality around, then you'd probably see this. Shaded there, and shaded there, right? Shaded, not shaded, shaded, but continue to be shaded because that would be squared. So that would be the graph of my solution, but I didn't ask for the graph. I asked for the, well, I didn't ask for anything. Give me solve. If I ask for the solution, you would have to come in here and say, all right, between -3 and -1, inclusive, and then how do I include 2? Two. You could put bracket 2, comma 2, bracket if you want to, but why not just say and 2? That's a little easier. You all with me? So these are polynomial inequalities. You should remember that, but if you don't, hopefully this kind of reminds you. But again, find out where it's equal. Those are what we call critical numbers. In calculus, this is a really big deal. We are constantly finding critical numbers, except sometimes critical numbers are defined a little differently, but it's the same idea. And then to determine what's happening in between them, we always just go back and check. We do it with derivatives, second derivatives, concavity, increasing and decreasing, all kinds of different things, which is not difficult, but it's this kind of idea. So you need to have this in play, just knowing you've got to go and check in these regions. All right, so this is an inequality that's a polynomial. But what I want to also show you, and it's a little trickier, quite a bit trickier if you're not careful and don't get it down, is what do you do when you don't have polynomials, but rather rational functions? So a rational function we've just been studying, right? What's the difference between a rational function and a polynomial? Or how about not rational functions, rational inequalities? Because these aren't going to be functions. These are going to be just inequality signs, maybe an inequality and equal, and no x and y, just x's. So what if I gave you, what is a rational function again? Come on, speak to me. Talk. People out there.
Where every x value has only one y output.
That's a function, but what's a rational as opposed to a polynomial?
It has only real rational roots.
Thank you for trying. No, not this time, but it's close. Guys, what's a rational function? We literally just talked about it for 2 days. Speak to me. Come. What do we do? What have we been doing the last 2 days? What's the difference between what we did the last 2 days? Somebody's at home going, I know. Do what?
The odds that don't have odds, you know, like all the roots are real, not imaginary.
Well, we are going to have real roots on these. We're going to be looking for those. Guys, what's the difference between a polynomial and a rational function? Polynomial?
Vertical line test.
What does it have, basically? Look in your notes. We're going to stick this one out until somebody speaks truth. You're starting to make me nervous.
Vertical line test.
Okay, you have maybe vertical asymptotes. I'm going to kind of go with whatever I got here. Might have some asymptotes and some slants and all kinds of stuff. What are these rational functions? What's the difference between them and a polynomial? It's written as the quotient of 2 polynomials. So basically, you've got a polynomial in the denominator as well. So you've got numerators and denominators. Now when I have numerators and denominators, as opposed to just numerators, what does that denominator bring into play? Undefined things, which are more places on your number line that can mess you up. Okay? So you've got to know the difference between polynomial and rational function. I know it's easy to sit here or sit at home and hear those words and they just kind of go in one and out the other. But you got to know polynomial, all in the numerator, all whole numbers. Rational function is basically polynomial over polynomial, which if you reduced it might end up being just a bunch of fractions added together with x's in the denominator. So here's a very basic, and then we'll get uglier, rational inequality. So you might have a rational function, right? Fraction with variable in the denominator, maybe greater than another. And again, I'm saying function, but technically there's no x and y. So these are just rational, not equations, but rational inequalities. So here's the thing that messes people up. They look at this and they go, well, that's not a big deal, man. Cross, multiply, and solve. And they think that's it. But I want you to think about what would you do right now mathematically to do this, and I want you to think about what impact that has in this very first step, because this is the step that messes you up. So somebody tell me what they might do, and I might correct a little bit, but don't worry about it. What would you do right now to begin this process? Okay, so cross multiply is really a shortcut, but what are you really doing when you cross multiply? Do you know? So you're multiplying both sides by the common denominator? Think about it. X minus 4, x plus 2. Now, if you're looking at this and going, I didn't know I was doing that. Well, check it out. If you think about it, that cancels, and all it really looks like I did is bring the x plus 2 up there with the 5 and the x minus 4 up there with the 3. But that's what I basically just did. Now, what do I have left? I have the 5 and the x plus 2, which I could have multiplied together, but I'm waiting on that for a second. And I have the 3 and the x minus 4. And here's the critical point right here. No pun intended with math humor. What sign do I use?
Oh, you don't know.
You don't know. Why don't you know? Yeah, you don't have any idea what x is. If x is 10, then you just multiply by 6 times 12, which is 72. That's a positive number, and you would not change the sign. But what if x is 3? If x is 3, you just multiply by -1 times 5, which is -5, and you would have to change the sign. And the reality is x could be positive. I mean, it could end up making these positive, could end up making them negative, but you have no idea. So at this point, the only thing you know, if you have no idea about the sign, what do you know? What would you put here? Yeah, I usually put a question mark. That's not real mathematical, but it was just to kind of help you along. But it's not equal, because there's not an equal sign. So I don't need to put a not equal there, because not, in the absence of having that line, we know that. But basically, I would have to bring that down and say, well, what I'm finding here are places where it's not equal. Are you with me? But I know nothing at this point about the inequality. I'm going to determine what the inequality is doing by doing what at the end? Checking. Same thing I did here. I don't care about the inequality when I'm figuring out where it's equal, and I don't care about the inequality when I'm figuring out where it's not equal. So at this point I have 5x plus 10, 3x minus 12, 2x negative 22, and x can't be negative 11. But if you right here, if you just bring down a greater than and tell me x is greater than negative 11, then you just got smoked on this problem. Like literally, I will give you 0 credit because you have shown me absolutely nothing that you've learned new. You've shown me that you can do an Algebra 1 problem with cross multiplication. And that's nothing that I've taught. So all you should have from this is this. But wait, is my number line just going to look like that? Because where else is this forbidden to have an x?
If there's a 0 in the denominator.
If I get a 0 in the denominator, when does that occur?
4.
At 4, x can't be 4, and x can't be negative 2. So I got to mark that negative 2 as can't be, and I got to mark that 4 as it can't be. And then I go and check. So these to me are much trickier than these because you don't have any of those what we call implied domain restrictions. Here, it was implied that the domain was all reals. because it's a polynomial, right? Here, wait, it's a rational function. It doesn't exist at VAs, so I have to include those. And then I have to find out where it does exist, or maybe not exist even further. And I got to mark those, and then I have to check. So I don't even have that. Actually, yes, I do. So right here, when you start checking these, you end up being shaded here, and you end up being shaded here. Now, here's the tricky thing about these. People say, well, can't you just alternate here because there's nothing squared? Man, with rational functions, you see some weird things. You really do. So just when somebody says, oh, I think I got a pattern, another problem will show up and shatter it. So you might be able to come up with something, but here's the thing. It's not like we do these every day. If we did them every day, I would be a specialist, right? I would figure out every possible scenario. They don't show up a whole lot. It's a good little math team question, but I mean, honestly, your math team days may be over. We'll see. But this is what I would just check, same as I would do here. Save your brain cells for more important things. So right here, your final solution would be -11 to -2, union or comma, doesn't matter, or whatever makes you happy, 4 to infinity. Right? Okay, now let me show you something dirtier. Now you may notice that in the process of doing these problems, I'm always picking and creating problems where there's some space in between these numbers, so it's easy to plug in a whole number. Vestavia, this is what your number line is going to look like on Vestavia. When you're going to go, all right, I got something at -2, I got something at -1, I got something at -1/2, I got something at 0, and I got to check the -3, -1.5, -3/4, you know, -1/4. They give you horrible numbers that you have to go back and check. And honestly, and it's a ciphering question. So if it were me, if it's a multiple choice, it's not a big deal because you can look at their answers, right? You can look at the answers, and if they give you that, you're like, oh, they said it's in between here. Let me check a number and make sure, just kind of verify what they have. But if not, I would probably check one of them and then just alternate the shading and just hope. Because more than likely that's the case, but that's what I would probably do on a ciphering question just to get it in time. All right, but I try to give you some spacing on your test, so at least you can check with whole numbers and not make your life completely miserable. This would be more of a kind of problem that you would see. So let's check it out. What about this? So the problem is going to say solve. So even though I'm going to use a number line to solve, that number line is not my solution. That's the graph of it. I want the solution at the end. All right, but the graph is probably the best way to go about that. So anybody got any ideas what they would do with this? Multiply by the common denominator. Go ahead and get rid of all those denominators. And sure enough, when you factor this to determine that, that was really nice of me, wasn't it? So you're going to come in here and multiply each side, which ends up being each term, right? Because when you distribute that in, and then you cancel, People try to take so many shortcuts with this. I really don't know why they do that, because it's really not taking me that long. But what do you think the biggest mistake is? And it happens right here. People just bring down that inequality. And if you just bring that down, you're toast. Now, if you bring it down and then ignore it, the problem is people bring it down and they go x bigger than -11, and they shade across that, and then they put a couple open circles, and they end up having this shade. You don't want to do that, okay? You don't know about it. You got to just check. So right here, I'm not going to bring down the inequality. I'm just going to bring down the what? The equal. So in this case, I'm going to actually find out where it's equal. I'm going to have a colored in circle. But in addition to this colored in circle that I'm about to find, which ends up being what, 6x 30, x equals 5. In addition to this, what do I have to make sure I notice? That's right. I'm coming alive right now. So x can't be 3, x can't be negative 2. So I've got all my critical numbers. I mark my critical numbers on a number line. So I'm going to mark the negative 2. It cannot exist there. Cannot exist at 3. Does exist at 5. And you can see I've been kind enough to leave a whole number in between there for you. I'm pretty sure I do that on the test. And then I just got to check. So check, 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 check. And after checking everything, I believe I ended up getting negative infinity and negative 2. Oh, I'll tell you what, let's just suffer through this just to give you a feel where it's not super pleasant. But watch, if I plug a negative 3 in here, it's going to be a lot uglier check than if I plug it negative 3 in there. So slow down, here you go. Negative 3 there would give me 2 over negative 6, or negative 1/3. Negative 3 in there gives me 4 over negative 1, or minus 4. And negative 3 in there gives me a negative 6 times a negative 1, which is a positive 6, 22/6. Well, it's pretty easy to see that a negative minus a negative is a negative, and positives are bigger than negatives. So that's true shading. But literally, your checks are going to be really annoying on a problem like this. This is going to be probably one of the problems that takes you a little longer than some of the rest. And then when you check this next one, it doesn't work. And when you check this one, it does work. So I guess if you ran out of time, you might go with the if in doubt, it alternates. But if it were me and you had the time, definitely check each part because you do not know that that's going to happen. Yeah?
Why is that one equal to and not equal to?
Just because of that. On this one, the inequality we check by shading, and then the equality we bring down. Here, the inequality we find by shading, but it wasn't equal, right? There was nothing with it.
Oh, okay.
So if there's nothing with it, we assume it's not equal. They really, I mean, I have seen stuff where they write this when it's greater than, but not equal. But it's like antiquated textbooks. I just don't do that anymore. I didn't do it much ever. But that's how you determine whether it's shaded or not. But anything in the denominator, obviously, is not shaded. Are y'all with me? Now, I want to show you a way you can cheat a little on your test. It's not really cheating because I'm going to put this on the calculator portion of your test. So your test might have 3 or 4 questions, and I'm going to say use your calculator. And I'm going to be asking you maybe to find a root of a polynomial. So you graph it, and it might have 4 roots. I'm going to say, give me one of them. All right, I would pick the one that's probably not scrunched up with a bunch of others, the one that's sitting out there, easiest to find a left bound, right bound, give me the x value, right? I might ask you for what the max is. So you go in there and you find out the maximum value. And what is the max? Is it the point? A max and a min is always the what?
Oh,
it's the y value. It's not the point. If you give me the point, I'm going to take off. AP literally will give you a question, find the max. And they'll have the point there. They'll have the x value. They'll have the y value. They'll have a lot of distractors. If you pick the point, you just missed it. A max and a min is always a y value. So you would find that y value using your function. But I'll also ask you to solve one of these. But it'll be in the calculator section. And I want to see your work, but I'll have a note. I'll say, show me your work. And then I'll say, you can check with your calculator if you want. Now, this is what's cool about this. If I took this problem, all right, I want you to think about it. We got it solved, right? If I took this problem back from the beginning, and I do this sometimes when I don't want to do all the checking. I kind of cheat a little bit. If I did this and moved everything to the right side, so if I move this over and this over, I would end up with this, would I not? Minus the 2 minus the 4. Right? Now, what if instead of having it on a number line, I went, I'm just going to think about it as a y. If I graph it as a y, does this make sense to you? If I put a y in there, then all of a sudden now, I have an x and a y axis, right? And if this is y less than that, what would I have been shading? Whenever you have an inequality, it's y less than, and you sketch the curve or whatever it is, where do you shade? Above or below. So y less than would be below. If it was y greater than, it would be above. Well, what you're going to end up having, if you graph that, which you can do on your calculator pretty easily. By the way, do you all know that there's a fraction button on your calculator? Does everybody know that? So if you hit the fraction button, just type this in and then go minus to another fraction button, minus another fraction button, be nice and clean. This is what your graph will look like. Something like, I don't know. You'll see this and you'll go, wait, if it's y less than, I would be shading below. Where does that affect the number line? Y'all seeing that? So this is a great way to kind of verify your work, and you'll have your calculator and test. Honestly, if it's taking me forever to do those first 4 parts, you know, maybe finish your test and come back and go, hey, do you mind if I pull my calculator out and play around with number or whatever? And then I'll probably say yes. But, so don't get bogged down in this and spend 20 minutes, because it does take probably a minute to get your calculator and type all that in there. But you're going to graph it. You can actually graph it with an inequality using the relation symbol, but then it alternates the mode of your calculator. I just say graph it, and you'll see this curve, okay? And then say, all right, less than would be below. So that goes, all right, anything below it, that's where it would shade the number line. Not shading it, not shading it. And that can really help you with your shading, and then you don't have to come in there and guess and check so much. You could literally just solve it. Find those places. So you could show me this work to solve it, but then all the checking, which is not a whole lot of work to see anyway, because you're just scribbling around on the edges, trying to figure it out, you could just graph it and go, oh, that's where it's shaded. And if it's y greater than, then I would be shading above, right? And above would be all through here, so you have it shaded there, and all through here, so you have it shaded there. But not in this case. So in this case, I would say, you know, negative infinity to negative 2, and 3 to 5. Whoa, 3 to 5. Right? Not too bad. We've got a little time. Let me just show you that on my calculator.
Are you going to be able to ask you, like, if you have a problem with the calculator, like, questions about it, since it's our first time using it on a test?
Not on the test.
Or no? Okay.
So ask me today, right now. Ask me, send me an email, and I'll include it with the review tomorrow. We can just talk about it. And I'll pull something up right now, and this, you might be able to get your questions answered now.
Oh, I don't know. I just...
But no, by the time we hit this test, I remember I normally put them on the first test, all the calculator stuff, but I gave y'all that extra time. So really this is like the second time they were going to show up. All right, so I'm going to grab this thing. So let me show you. You might want to just do it with me and troubleshoot it. So here's your graph, menu, window, standard. So it's a nice standard window right there. And if I was going to try to do this problem with it, I move everything over. So I'm going to be graphing y less than or equal to that. Now I don't have the less than or equal because it's going to be an equal sign. So check it out. I'm going to hit tab. And I'm going to have 22 over that fraction. So here's my fraction button. 22 over x squared minus x minus 6. Minus x minus 6. Come out to the side. Minus fraction button 2 over x minus 3 minus fraction button 4 over x plus 2. So I've got all of that typed in nice and neatly, right? Now this is going to graph basically a little wiggly polynomial, except probably between this is probably going to go way down right here, way down because there's 5 apart, and the further apart, the more it dips. So it's probably not going to look as pretty as my little graph. Probably going to see a what?
Yeah, that's what popped up for me.
Well, the problem has a wait.
Hold on, does that make sense? Okay. Oh, of course it doesn't look like this. This is a polynomial. My bad. We don't have a polynomial. We have a vertical asymptote there. What am I doing? Vertical asymptote here. Okay. So we actually have vertical asymptotes at -2, which makes more sense, right? And at +3. But it's still going to make a lot, and then at +5 it crosses. It's equal there, right? So it's equal at 5, VA is there. But I can still see from this graph, y less than. So where would you shade here? That part holds. Sorry about the polynomial. Sorry. So what do we got here? Y less than would shade below. So below this curve, VA means it's open. That would color in all this graph. Right? Below this curve would not color in any of that, right? Right? Another VA, open. Below this curve would color in that section. And below this curve would not color it in. So once again, all the way to -2, 3 to 5. So yeah, if it was a polynomial, it would have looked kind of what I did, but I totally wasn't thinking this is a rational function. Rational functions have vertical asymptotes, so obviously the graph is going to look different. Yep.
Can we do all the way find like the min roots and stuff? Or just like
Yeah, we can use this actually. So this would not be the min because it goes down forever and there would be no max, but there's a relative min. Now, I probably want to ask you about a relative min because I'm going to keep talking about that. But there's a relative max right there. Okay? So that's the highest spot in that little area because it increases, decreases. That's a relative max. So let's go find it. If I was using my calculator, I would say menu, analyze the graph, max 3, and it says give me a left bound, so I'm going to just rub on that thing until it starts moving. I'm going to go to the left of the peak of the max, and I'm going to go to the right of it, and I'm going to click, and look, it gives me the point, but what do I want?
what?
The y value. So the relative max, not min, would be -3.956. You with me? And I would want you guys to get in the habit of rounding to 3 decimal places. And the reason why I say that is in AP Calculus, we always round to 3 decimal places. Always. Which is a little annoying because AP Physics, I think they always round to 2 decimal places, which it makes no sense to me why AP would do that. But here, always 3. But don't give me the point. If you give me the point, you're going to lose half your credit there for that problem. And people do it every year, no matter how many times I say that. And they do it in calculus at the end of the year after I've said it a million times. So if you can get into your head that min means minimum y value, you'll be in good shape. And if I said find the root, this only has one root, it appears. And it's pretty clear that it's at 5, but never know. In AP, that could be 5.027. So what do? Menu, analyze, find the 0. Looks like it's over here. So, and by the way, do you know that you don't have to use this cursor? If it looks like it crosses at 5, look, I could just go 4. You'll see the number 4 pop up on the screen and hit enter. And it'll mark it at 4. And then I could go, say, 6. It'll put that on the screen, and I can hit enter, and it marks it at 6. And sure enough, there's the 0 at -5. So you don't have to use the cursor thing. I use the cursor when I can't tell what it is. Like if you have some crazy number line that's out to 10,000 to the right, and you don't even know where you are, then yeah, click, and it gives it to you.
Why is it so negative?
It probably isn't -5. It's probably the bar from that. But you're right. I probably would have written -5 by mistake. But watch. If you ever get it all combobulated right there, go down and put your hand on it. Click on it to close your hand and move it up. Yeah, that was just the bar. And it's 5. Yeah, sometimes when it puts in you can grab that equation and pull it down too, so it'll be out of the way. Or delete it. It is kind of nice seeing it there, but to me, the old 84s, you didn't see the equations or anything. You could, if you traced, it would show it up at the top. But y'all with me? Any other questions on anything?
What's the fraction button?
The fraction button is right over your division sign. See the little,
Yeah.
so just control that or whatever that is. Yeah.
Is there ever gonna be like, another line that doesn't shade? Like nothing that we can't shade that we think that will be
It's possible. Yeah, I mean, it is possible. I guess. I have never seen one, but I'm sure I could probably make one where no matter what, it just doesn't. Like, think about it. What if you ended up having something? Let me get this off the screen. What if you had something that you come in here on your graph and you mark your graphs like this, but you end up having just a whole bunch of, think no x-intercepts, but a whole bunch of volcanoes. So the graph does something like this. And it was y greater than. So you're shading up on everything and you go, I guess that's a null set. Whereas if you were going, like if this was a y greater than, blah, 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 by the time you got it finished, everything would be shaded above, that's nothing on the number line. Whereas a y less than or equal to would have everything shaded except the VAs. So it's possible, but I have never given one like that, nor have I seen one like that. It usually is something like this. All right, so if you have y less than, probably looks more like that. But yeah, that's a great little check for you, should you see any of these problems. I mean, you're going to see them next week on the test, probably see them on a 9 weeks test, probably see them on an exam. After that, you're not going to see this stuff in calculus, I doubt. I can't think of where the inequalities comes into play much. And you guys are going to pass, barring just utter laziness in AP Cal, you'll pass the AP test most likely with 4s or 5s, all of you. And if you do that, you're not going to be taking general math or college algebra. So this will be a thing of the past unless you decide to give yourself to the community and become an educator. Yes?
On the test with the X and Y charts, are we gonna have to do that? Like, are we gonna get
Just to find a couple extra points?
Yeah, because I mean, you get so many decimals. Like, do we? Well, that's just
Yeah.
a fraction, I guess, but
Okay,
like,
so the short answer is yes.
okay.
The rest of that question is, I'll probably give you the X coordinates I want,
Okay.
and yes, you're going to end up with stuff like 57 11ths or 37, 15ths. So my thought on that is, what's 57 11ths ballpark? 5, and you won't have a calculator on that part, so you'll go, oh, well, let me just go to -2 up 5 and just put a point somewhere in that neighborhood. And this, you're going to look at this and go, what, 2 and 7/15, about 2.5? So you'll go to 3, and you'll go up 2.5. So it's more of a, I'm asking for that point more along the lines of, so it'll give you an idea of where to put the curve. Is it there? Is it there? Is it there? Oh, there's a point there, so it's probably something like that.
But you'll give us.
I will give you the X values I want you to use. Because otherwise I got to do every X value to check to see if your X values are right. Yeah, and just be careful when you're doing the math on that. Make sure you write the actual fraction. Anybody else at this point? Again, if you start your homework, knock it out, and then maybe look over the review sheet. And if there are any problems where you go, okay, that's a red flag to me, I don't even remember that. Which there very well may be, right? Just a few moments ago, I said, what's a rational function? And y'all were like, So if that happens, send me them. Just go, hey, would you do 27 and 45? Would you do 15 and 17? And I'll just make a list, and then I'll come in here, and we'll just go through the ones y'all talk about and the class wants to talk about. All right? All right, guys. Good times.